Hey Algebra 1, we are in section 11.3 and we're talking about radical equations. A radical equation is an equation where you have literally radical expressions are contained within the equation, particularly radicals that have radical expressions with variables. So these two are examples of radical equations. Now the idea of extraneous roots will be better seen when we do some examples, but basically extraneous roots refers to answers we get when doing everything that seems totally right and totally normal to solve the problem that don't work at all. So extraneous roots turn out to be more like solutions that do not really satisfy the equation as true answers. And we'll see that in our example. Example 1, radical equations with a variable, freefall height. Two objects are dropped simultaneously. The first object reaches the ground in 2.5 seconds, and the second object reaches the ground 1.5 seconds later. From what heights were the two objects dropped? So in this problem, we're going to be searching for height, the h value, and we're given time. Let's see if we can make out what's going on. The first object, let's call it object 1, was dropped and it took 2.5 seconds to reach the ground. By the way, h will be in feet given this equation. So the first object took 2.5 seconds to reach the ground, so we'll put a 2.5 here, and we can now solve this radical equation to figure out what the original height was. Here, let's try the same thing. The temptation might be to put 1.5, but when we look more carefully at the problem, it says that the second object reaches the ground 1.5 seconds later. That means they were dropped at the same time. This one took a little bit longer to fall. 2.5 plus 1.5 is the amount of time that this object, the second one, was in the air. So when I add those two values together, I get 4 seconds total for object 2. So now what we're going to do is solve it. Now to solve a radical equation, the first thing we do is isolate the radical. So to do that, I'm going to multiply both sides by 4. And then on this side, I get 10 is equal to the square root of h. Squaring both sides, because that's how I undo this radical, but what I do to one side I have to do to the other. I end up with h is equal to 100. So what this tells me is that the original height of the first object was 100 feet. Following along over here, I'm going to do the same thing. Solving for h, I have to isolate that radical, multiply both sides by 4. I end up with the square root of h is equal to 16, and that follows up with squaring both sides. And I get that h is equal to 256. So 256 feet was the original height of the second object. So here's another radical equation with an expression. So here we have the expression, the square root of x plus 1, and we need to solve for x. What you do when you have a radical equation, the first thing you want to do is isolate the radical. So we're going to do that by subtracting 7 on both sides. When I do that, I'm left with this. The square root of x plus 1 is equal to 3. Finally, I square both sides. When I square the left side, I get x plus 1. Squaring the right side, I get 9. And now, this looks like a very typical linear equation that I would get 8 as my final answer. Anytime we are solving radical equations, it is really important for us to take whatever answer we get and go back and check. And so I'm going to do just that now. X plus 1 plus 7 is equal to 10. Even on your assessments, my expectation is to see you checking answers in this way. So I'm going to plug the 8 back in, and when I do so, I get 8 plus 1 plus 7, square root of 8 plus 1 plus 7 is equal to 10. And I'm going to check that out. 9, the square root of 9 plus 7 equals 10. Square root of 9 is 3 plus 7 equals 10. 10 equals 10. Perfect. Example 3 has a variable on each side. And so this is a little bit more tricky, but the idea still is the same. To solve this problem for x, right, I still need to get x out of the radical, out from underneath the radical. So I'm going to isolate the radical, which fortunately has happened already, and then I'm going to square both sides of my equation. So squaring both sides will yield this. X plus 2, right, is equal to, now before you write x squared minus 16, remember x minus 4 times x minus 4 is what x minus 4 squared means. And so I have to FOIL it. X squared, I'm going to get a minus 8x, and then I'm going to get a plus 16 if I were to go ahead and do all of the things we know to do. How do we solve something like this is the question. You remember this is really simply a quadratic equation. We're going to move everything over to one side. We're going to set our equation equal to 0, and we're going to see what we can do. So when I do that, I'm going to subtract 2 on both sides. I'm going to subtract x on both sides. I'll be left with 0 here. And on the right side, I'll have x squared. That's a minus 9x, right? Remember subtracting x on both sides? And now I'm going to subtract 2 on both sides, and I get plus 14. I hope that made sense to you. And if you needed to do that in 2 steps, totally fine. The next thing I'm going to do is see if I can factor it. Now, I'm not going to be disappointed if I can't factor it because I know that I can factor and I can use completing the square or the quadratic equation to solve any quadratic formula rather, to solve any quadratic equation. All right? So let's go ahead and see what I can do. 14, two numbers that multiply to give me 14, positive 14, yet add up to give me a negative 9. And those numbers are negative 7 and negative 2. Fortunately for us, we can factor. And that works. I feel confident that that is the right answer. And so with that, that tells me that x is either 7 or 2. Those are my two answers that I get. But before I box it off, I need to check it with the original problem. Not any of the intermediate problems that I created. I've got to check it with the original. And so when I do that, I go back and let's check the number 7 first. So I'm checking out that the square root of 7 plus 2 should equal 7 minus 4. 7 plus 2 is 9. Square root of that is going to give me 3. And 7 minus 4 is 3. So I feel confident that 7 works as an answer. Let's try 2. So I'm going to plug 2 in. 2 plus 2 is equal to 2 minus 4. That's what I've got. 2 plus 2 is the square root. Is really what I mean is the square root of 2 plus 2, which is the square root of 4. 2 minus that is a negative 2. Square root of 4 is 2, and that is not equal to negative 2. So 2 is what we call an extraneous root. It's an extraneous root or an extraneous solution. And if you go back to the definition, where was that back in the day, 2 years ago? Extraneous solutions are solutions that do not satisfy the equation as true answers. So let's think about what that means. So we worked hard, we checked it, we did the thing, we got two solutions, 7 and 2, but it didn't satisfy, both 7 and 2 didn't satisfy the equation. It didn't make the situation true. So why did that happen, you might be wondering? We did everything right. The fact of the matter is, when squaring both sides of an equation, you create situations that were not true to be true. So for instance, if I squared both sides, I would get 4 is equal to 4. And technically, that's what I did in this next step. That's why when you solve and you check for extraneous roots, you check your answers, you're going to plug it into the original one, not into an intermediate equation, because it would have worked if I had plugged it in here. If I plugged 2 in here, it would have been totally fine. And that's because of this squaring of both sides. All right, that's it. If you guys want to do some extra problems, if that was not enough for you, which totally makes sense if you're feeling like, what? Then let me know and we can do either another video or we can do a Zoom chat and discuss more things to do. But for me, that's the end of the lesson, and I'll give you an assignment to see if you can practice some of the things we've talked about. Let me know if you have any issues, and I look forward to talking to you soon. Bye-bye.